Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our Earth.
PKphoenix.
Appreciate it.
All right, I got that's a new well, I guess he's not new because he already has the Globe Earther role. Is PKphoenix. Are you there?
Oh, so there's a globe Earth the role? Like how does it look like? See, I didn't even know that.
Like you have to know your globe, man, in order to get the.
Yeah, it's
okay.
Yeah, I came in here a while ago.
Welcome back, man. Welcome back.
It's been a while. Came here to have a little bit of a listen.
Oh shit.
Yeah, I think I've seen you before. It's been a while.
It's been a long while. I had a couple of conversations with you guys in here.
Roboting back.
Just a little bit roboting, yeah.
Yeah, a little bit.
Am
roboting.
Damn, we were about to get into the.
We wanted to talk about the shape of the Earth.
Yeah,
internet saving me.
We have to enter the Thunderdome.
Nope, still going out. Never mind.
Yeah, still robotic.
I'm going until my shit stabilizes.
Yeah. Do you have lag on your side, or does everything sound perfectly on your side? Because on our side it's kind of choppy.
I was actually just playing a game. You guys sound fine, but I obviously don't.
Okay.
I think my internet may be about to go fully out.
Okay, Heretic. Okay, sorry, really quick. Even though you're roboting, can you try to give us the what was the proof that you have? Like the best proof that you can think of for the globe. Heretic.
I think he's in a robot. Oh, Heretic?
Yeah. Well, I was gonna ask him anyway, but Heretic wants me to get straight to the fucking point. He doesn't like to waste time. So yeah, he wants get to the. Do you have any globe proof? We got to get to the point. Heretic doesn't like wasting time. Okay, he muted.
We need you to fix your internet. So you can come back.
I'm trying. He's trying.
Really
He's trying to get it out. Heretic.
It's really important. Maybe you should reset your video game. That's probably what you should do.
He's trying. Heretic. All I got to tell you is he's trying, bro. We're trying.
Can you point your Discord to another satellite or something?
use gravity and point it to the ISS. Point it to the ISS. Just use gravity. Come on. Use the force. The imaginary non-force force.
The curvature is getting in the way of his router.
Hey, honestly, if believing in the imaginary spinning space monkey religion gave me powers like Star Wars, I might actually be tempted. Just saying.
Whoa.
How dare you? How dare you?
Bro.
I'm just kidding, guys. I never go back. Once you go flat, you never go back.
Yep. True story. Oh, I do have a good question, okay? I think it's going to be a good question. So, do you think, okay, let's put it this way, okay?
Yeah.
How much money would it take for you to become a globe earther? Right?
That's a bribe.
Okay, no, be honest, because my wife asked me that question, and she got me shooken up for a little bit. But let me ask you guys.
My answer would be no amount, because in all honesty, even if you were given like $10 billion, right? Like, let's just throw a weird number out there, $100 billion. Like, oh, you'd never have to worry about money ever again. You would have to spend the rest of your life arguing for the globe. And that would get so tiring, dude.
Yeah,
so tiring.
Yeah, especially when it comes.
Especially when you know what to lie.
Yeah, definite. See, the thing is this, right? So, she showed me a video or whatever, or she was telling me a story about a video. So it was this chick or whatever, the chick or dude. That person is a vegan, and of course they don't eat meat, right? And so somebody came along and said, "Hey, I give you 5 grand if you eat this piece of meat." And the person's like, "No, I wouldn't do it." And then, the dude goes like, "Okay, I give you 10 grand." And guess what? That vegan person ate the meat.
High price hooker. That's all that is. A
And
high
then-
price hooker.
Yeah, and then everybody start kind of laugh. It's because like, wow, so this is how much it takes for you to basically betray yourself. Like
Yeah,
Wait, I got quick question. Did the vegan donate that $10,000 to PETA? If they didn't,
I don't know. I don't know. But yeah, so now that question, so my wife asked me like, okay, so how much money would it take for me to become a flat earther? I said, well, I would take all the money. I said I would take $100 million, all the money, but then I just lie, and I will just take the money and run, and then later on I'll start talking about the flat earth again. She said, well, there's certain rules that come with it. If you do that, then they will have the right to take back all the money. So I said,
Right.
well, I don't think I can do that. It's because maybe I take the money and 10 seconds later, I'm still a flat earther. I might just say it, so might as well. So
it
no
takes
amount
part
of money.
your soul. It takes
Yeah,
part of your soul.
no amount of money would buy me from being a flat earther. Period. It just like it's with me. It's stuck with me forever. When I die, I take it with me. I guess that's how I see it. So
Okay, PKphoenix is back. You there? Are you roboting?
No, I think my VPN was fucking me up. I don't know why it was lagging me, but since I turned it off, everything went back to normal.
Welcome back.
Yeah,
Well,
all right. Yeah,
was
we can hear you
your
better now.
VPN putting you like on another planet, or what was
China.
going on?
yeah, another planet. It was in China, exactly.
It was spinning too fast.
All right.
Okay.
Uh,
Here's my question. Right. Here's my question.
Yeah.
All right.
Yeah, what's up?
So, all right, let's get into this. Hold on. Let me check if Heretic is listening. Okay, he is good. Okay.
he is.
All right. So, all right. So, what is the best proof you got of the globe?
Well,
Best one.
I don't know about the best, but one of my favorites.
Yeah. What's the favorite?
I wasn't planning on
They only
coming
want
here
the
to the meeting
best.
tonight, by the way.
Here we go.
Oh, it is one of the best too. It is one of the best too.
Yeah. Let's hear it.
It's the same, you guys actually like to use the same thing as well, except for the whole counter argument. Lake Michigan. How you can see the buildings on the other side of Lake Michigan.
Uh huh.
Huh?
Yeah.
What's the expected drop rate, or like
Oh, you're gonna have to make me pull my shit out. I'm gonna have to get reference materials. I wasn't coming here to do all this. 1 sec here.
Okay, well, okay, yeah. Let's get it. Yeah, might as well. We might as well get into
Oh,
it.
we already got it over here. And now my dog wants to get active with me too. So
Your dog knows the Earth
He
is flat. I just
posted
want you to know
already, actually.
she may think so.
that.
That do be a dog brain after all, am I right? Ain't that right, girl? Yeah.
No, wait.
So the main reason why I say it is the same arguments I've heard. Like I said, it's been a while since I've debated this. I just recently even came back into this argument. But one of the things that I've heard a lot of flat earthers point out is that being able to see the buildings on the other side of Lake Michigan is the damning proof showing that the Earth is flat, because because refraction isn't a thing for a lot of you guys, and you shouldn't be able to see any of the buildings on the other side.
Okay,
Due to
so do you want to? So let's get into Hold on. Let's get into refraction. Okay, so let me ask you this: what is required for refraction to happen?
A medium for light to pass through.
How many?
Right. Hold on. Wait. Hold on. A medium for light to pass through. Right. Okay. So let me ask you
Everything
this.
refracts.
Let me ask you this. Hold on. Let me ask you this. The medium that we're talking about here is gas. It is atmosphere, and the atmosphere is gas pressure. Correct?
Yeah, atmospheric pressure. Yeah.
Right. And so you have to have that medium on the Earth, right? It can't go anywhere else, right? It has to be on the Earth, right?
Yes.
Right. So what
Okay.
happened? Hold on. So
Mhm.
what happens when you put gas right next to an open vacuum?
You know what? Well, it's not, as you know as well, space isn't a vacuum. It's a low pressure. It's an extremely low pressure system.
Doesn't matter.
How do you know what
It would
space
still
is?
fuck off. It would still
No,
fuck off.
because this
Hold on,
beautiful
hold on.
thing
You can't say that. Hold on, let's correct that. Technically, by definition, any system, any area where gas is below 1 psi is defined as a vacuum, which would
it's
be
not a perfect vacuum.
yeah. Oh, hold on, buddy. I didn't say perfect vacuum. I just said vacuum. Can you hear what I'm saying?
All right, don't be getting snippy already, man.
But
Relax.
I'm saying
I
it's
get
like it's not technically a vacuum. That would technically be a vacuum. 10 to the negative 17 torr would technically be a vacuum.
You're right.
Yes.
Let me correct myself. It's not a perfect It's not a perfect vacuum.
Okay.
Irrelevant point either way.
Is there? Do you know of any? Have you ever witnessed or have you seen any physical demonstration in real life, without assuming the existence of outer space, right? Without assuming that exists, have you seen a demonstration of open vacuum right next to a gas pressure gradient without any physical barrier?
You see the whole issue
Why
about
are
this in
why are
general.
we jumping to this? Didn't he
Yeah,
have some
yeah.
Because
like
he mentioned-
Michigan?
I can address this too, but that wasn't the original point. But I can address that as well. And if you
Can
want
you
to talk
just
about
go
that
to like
instead.
Michigan, and you can tell us
Yeah.
about how that's proof?
Yeah.
Really? Sure.
Yeah, we were talking about it, and then he brought up refraction. So then I asked him, okay, so what is required for refraction? He told me you need a medium and you need light.
It's a bit of a
guess
tangent.
what?
Right. So how many mediums do you need in order for refraction to occur?
At least one.
2. You need at least 2.
That
You can
seems
go
to me,
look
but
that
alright.
up.
I'm gonna take your word on that. I'll take your word on
You
that
want me
one.
to drop a citation?
Sure. I always like
Alright.
citations. Is that gonna be in the live stream voice text thing?
Yep.
Cool.
So anyway, going back to Lake Michigan.
Yeah. I was just gonna make the connection that you need the medium. You know, you have to have that medium there, and if there was outer space vacuum, it wouldn't be there. So that's why.
We can circulate back to this, and I can answer that real fast. Gravity is the answer. The reason why our atmosphere doesn't leave us to begin with, but we'll circle back to that one in a bit
Okay.
because I know that's a whole separate conversation.
Yeah, we can get back to that.
Yeah.
Did you want to say anything?
So, firstly, did you get that? Who had that citation for that, or where is that one?
I'm getting it.
Okay, my bad.
I'm
Not
gonna
trying to
keep
rush
it
you, man.
simple. I'm gonna keep it simple with physicsclassroom.com. That was the first one that popped up. But I'm gonna go ahead and find an actual EDU citation for you as well.
That works too. Ah, yeah, Snell's Law. I haven't seen much about that. I haven't looked at Snell's Law in a while. I haven't looked at Snell's Law since I last got interested in the whole flat Earth stuff. Either way, or anyways, I should say.
Do you accept the University of Texas at Austin?
Yeah, I accept
Did you accept
universities
that?
in general. But I'm also not too upset with that. It makes sense why there would need to be 2 mediums to begin with. It has to refract off something else, anyways, in order to refract.
'Cause if you're standing in the medium, then you're not going to see refraction.
Medium
You have
is
to be
not
another medium.
it's media.
Medium.
Anyways, going back to our original point as well, though. Thank you for the reference. So, whenever you see all the pictures of Lake Michigan, and if anybody has them on hand, I might be able to find some while I'm talking about them too. So there's the pictures that they bring up to prove that the Earth is flat, being able to see the buildings on their side. I have still yet to see a picture of the bottom of the buildings, or the bottom of those buildings, the trees, the roadways, the other things there as well.
Can you drop a
And that
picture?
is, yeah, I'll have to go find one real fast.
And the only reason why I'm saying because I've looked into that as well, and I'm gonna go ahead and drop what the picture you're probably gonna drop. I'm gonna go ahead and drop a zoomed in version of that.
I've seen a few different ones, but yeah, go for it.
I mean, all I did was blow it up. So just give me a second. I don't know how far back this. So I'll drop this one.
Thing, or is it actually something that's there that it's
I'll drop.
bottom? So you can choose one. You can't have both.
If you go to 29
Wait,
after, right above
hold on.
Northern Rebellion, you'll see my double picture.
What was that one more time? I couldn't hear you.
I said you'll see my double picture at 29 after.
Yeah, I do indeed.
And then your poor dog wants attention.
And she really does. She was dead asleep until I started talking.
Hold on. Can I quickly ask you something? Were you just talking about, photographs of the Chicago skyline across the lake and how you can't see the bottoms of the buildings, and you're asking you were saying, oh, I wonder why that is.
Yeah, and at the same time as well, why you can't always see it, because there's also days where you can't see the other side at all. I've seen pictures showing the same thing.
So there's two answers I have for this question. The first one is there's an optical effect that would cut off the bottom. It's the same reason why we see boats disappear from the bottom up, even though there is no curvature of the Earth. It's an optical effect. But beyond that, beyond the optical effect, that is a factor. Something you should know about Chicago is that those buildings that are the tallest skyscrapers, they're actually not at the same level as the lake. They're actually about 2 or 3 stories below, or so. I'm not sure exactly how far, but point is the street level where those buildings are is actually below the lake, like significantly below it.
Where the streets are,
exactly why it is they built it that way, but there's, they build cities in all sorts of different ways for different reasons. But the point is, those skyscrapers aren't actually at the water level at the base. That's what I'm saying.
Well, that's fine. The skyscrapers aren't. That's fine. There, you can absolutely be below sea level while still away from the sea, but that doesn't excuse the other buildings not being visible.
I'm not sure
if that's asking why you couldn't see them,
but yeah.
Yeah, and for the skyscrapers, it does make sense, but not the rest of it. And also, though, the optical effect you were talking about. Yeah, the bottom.
You're complaining about not being able to see the bottom of them.
Yes. Of everything, including the streets and all the buildings on the shorelines.
Well, then perhaps you need to go to Chicago and take a drawing 101 course. Your confusion about perspective will be addressed.
I have a feeling it won't be. I'm here to have a good conversation.
Well,
don't start getting.
As am I.
Don't try to do.
Go ahead.
And I won't be doing the same to anybody else. Real fast though, I want to circle back to something real fast. What optical effect causes something to disappear from the bottom up instead of the curvature of the Earth?
It's very simple. So you see in front of you, when you're looking straight forward horizontally, there is an angle in which your eyes can resolve where, so like take for instance a ship disappearing. It's sailing away from you on the water, all right? Now the angle from your eyes, from where your eyes are, and below where your eyes are, which would be, a few feet from the surface of the water up on the ship. All right, that's where your eyes, if you were to draw a straight line from your eyes to the ship, only a very small portion of the ship would be above the water. All right. Now the angle in which that is a very small angle, and the angle above that is a very larger angle, and the angle below it is so small, and the angle above it is so large that your eye can't resolve it, even though it can still resolve what's above your eye reasonably well at a certain distance. So this is why it appears to disappear from the bottom up, because your eyes cannot resolve that very, very small angle of parent angle, I think it is.
This will go into another fun discussion then. I wish I came in here with actual materials pulled up. And I guess I can do both at the same time.
PK, if you look in the live stream, Miguel just posted a meme with a protractor and a building showing you how, like, from your eye level, looking straight out, the angle to the bottom of the building is smaller than the angle to the top of the building. That's angular resolution.
And the thing about angular resolution, though, same with your point here, is that no matter how far someone gets away from you, you should still be able to pull it back into focus, regardless. That's the whole thing about angular resolution.
Well, why?
No matter
Why?
how far away it gets. What do you mean?
That's an extraordinary claim. Why? Why would you say something like that?
A lens can still only, like, focus so much.
I mean, you're right. But you can still zoom if you have a good enough camera or telescope, anything along those lines. Alex, she's about to rip out my fucking headset cable. Girl, go lay down.
You can zoom in on
Hold
both.
on 1 second. I'm gonna go put her up. Or at least try and settle her down real fast. Give me 20 seconds. I'll be right back.
Yeah. It's alright. It's alright. Isn't there 2,000 feet still missing though? I mean, I'm assuming I don't know what the height of the. I guess
the tallest building in Chicago is 1,400 feet. So I mean, you shouldn't be able to see any of it.
So I got a question,
That's actually hilarious. That's actually oh man.
So I got a question. So the guy, the globe earther guy, he said that because the refraction, and that's why we be able to see it, right? So what is the number one proof, right? That or experiment or whatever that we can do to prove that that's not the case. It's not a refraction. If we so I don't know. I'm not sure, but I'm just kind of use a little logic here, and I don't know if it's logic or not. But what if we use infrared camera, right, to capture that whole city? So if it's behind the curvature, we can't.
No, sorry. That's already there's already infrared images of mountains that are 300 miles away plus, and it's like I agree. But yeah.
Okay, so maybe no. I'm just okay. But like I seen those footage, those pictures too. Yeah, and that it proved that there's no curve. Okay, but I'm just saying. I'm just saying about the lake. I'm just saying about that whole city, the whole skyline city, and just show to them to shut them up once for all, and show them the evidence. So maybe they can just. But you know what? Even if we have 100% proof, 100% proof. Guess what? They still gonna try to find more excuses and
they'll just complain about they'll complain about the quality of the camera. they'll complain when it's not good enough, and they'll complain when it's too good.
Yeah. Hey Kimbo, that's an excellent point. That was something that I noted a few months ago. I don't know how long it's been noticed by the flat Earth community, but I'm glad that you learned that on your own. That the sine wave for vision of seeing with infrared is longer. That wave is longer from peak to peak, and so because of that, there's less opportunity for refraction.
Yep.
If there was even any refraction there's less opportunity for it. So the fact that you can see further with infrared automatically kicks refraction out the window.
Yep. I do agree. See, the thing is, I think flat earther got smarter because that whole infrared thing. It's from the globe Earth side, right? They claim that they can see like millions of light years away, with the infrared, blah blah blah. And guess what? We used that motherfucker to debunk the curvature, and we did it, And now we're gonna use the same shit to debunk more of that, that globe Earth stuff. So
let's see what hopefully are you still there, PK?
Yeah, I'm back here.
Still there?
I was listening.
Okay,
didn't want to interrupt there.
That's all right, man. Your dog's your best friend, dude.
They are indeed. They're still in my room, but now they're laying down again. So let's hope that they don't decide to act up again. We got very pouty whenever I tried to kick them out. So
you were talking about how we should be seeing forever if it was a flat Earth, right? So
there is atmospheric interference there as well. So you would never be able to see all the way, but you'd be able to see.
Well, it happens very quickly.
Air interference. There's gaseous interference.
Mm-hmm.
Because you can see the more you zoom in, you see it gets foggier, right? So why would you not realize that the more you zoom in, it's going to get more and more foggy? So you shouldn't be able to see very far. Right?
Hold on. I need to pull
we were talking about zooming in. Yeah. Do you remember the boats? Do you see the boat gives you can zoom in on the boat? I don't know if they did that for Lake Michigan, but they did it you can do it for sure. It can be done. Not all the time.
Yeah, you can. And there's plenty of those as well. Actually, let me finish watching this all the way as well. The issue... I know the immediate counterpoint I'm going to have for this. That sailboat as well might not be in that picture, may not be past the point where you wouldn't be able to see it. It might just be too small for your eyes to actually be able to see it. It is a small object way in the distance. I don't notice it disappearing from bottom up in that picture.
In the GIF?
Yeah.
It's literally in the GIF when he zooms out, it's literally disappearing from the bottom first. Like
that's what I'm trying to look at and tell to see if it is or not. It looks to me in that it is just going back farther and farther. I don't see it disappearing from the bottom up in that. I see it pretty much disappearing altogether. I'm not. Hold on.
It is going.
No, I wouldn't say that.
What are you
we also don't know how far away that boat is. We know the general size of a sailboat. We also don't know how far away that sailboat is, or if it's supposed to be going.
Well, it sounds like you need to do some of your own observations instead of bellyaching about gifts. Or
the nice thing about this is I've seen
just randomly questioning him. Oh, me, we don't know. I don't know.
You know what's funny about it? Hold on. You know what's funny about that though? I am questioning it. I'm not completely discrediting it.
You're bellyaching about it.
I am pointing out issues that you also don't know about it.
Yeah, but
you also don't know the measurements for it too. Is the issue with
you're making arguments from ignorance.
As are you, because you also can't.
What argument have I made?
We're talking about the image on there. There are other factors that you don't know. That
what I said, what I suggested was it's time to start making your own observations. If you don't like those, is that an argument from ignorance? No, is that an argument from ignorance? Me suggesting you making your own observations. Thank you.
However,
recant.
Pointing out the sailboat thing or saying that I am belly aching over that when I'm saying that there are
belly aching, but you don't know anything about it.
So apparently neither do you. You don't know the measurements for it either.
Much.
The difference
now you're belly aching about me.
I'm not. It is funny, isn't it? The difference here is I'm not discrediting it and saying that it may not be what you're saying. You're taking it as 100% fact about all the evidence around it.
Your son has lost the plot. Okay. How about if you don't like that one, have you seen the original famed oil rig observation, the Black Swan, if you will?
The Black Swan. Yeah, it's been a while, but yeah.
Well, there we know where the oil rigs are. We know the observation height. So. Do you want to bellyache about that now?
I can, if you really want me to.
Where's the horizon in that? If you're aware of it, where's the horizon in that image?
I'm happy to see the picture again here.
Well, have you ever? It's not seared into your mind. You're going to bellyache about it, and it's not seared into your mind. Okay, go ahead.
You gotta calm down. Listen,
I'm calm, homeboy. You'll know when I'm not calm.
It's already.
You'll know when I'm not calm. Do you?
This is not
remember the oil rig? You remember the oil rig image, correct?
I have seen them before. I've seen a lot of these images before.
We just posted it right here.
Yeah.
Okay. We'll take a look at it. Where's the horizon?
What do you mean? Where's the horizon?
What do you mean? What do I mean? Where's the horizon?
Look in the image. A, B, C, or D. Just tell us the letter.
Oh, I see here. I don't feel like answering that one. But
okay, so you don't get to
actually look at the image here.
Oh my god, that's hilarious.
So that means that you choose the answer D.
Just say D,
you're
dude.
coping?
You're right. That wasn't a fair thing to say.
You would be
However,
the first
though,
one to
there are
answer
different-
D, just so you know.
It's simple. A, B, C, or D. Which one? Just give us a
It's hard to tell. It's hard to tell. But you can. I know that you also can calculate the horizon as well. But I don't know how to do that off the top of my head. Too. We could find out if we had enough.
Your best guess. A, B, C, or D. Your best bet.
Well, considering there's some funky shit going on with the ocean there too, you know what? Fuck, let's go with let's hit the B button there.
Okay, just a second. If the curvature is not at 1.22 miles, and you can see farther away like 10 miles, and I just did post you like 70 miles. Where is that curvature?
Where did you say? What was in there? About 70 miles?
You can look above. I did post it. It was done in 2011. Long distance telescope observation. All the data. You have all the data. Go to that place and try to prove to us that there is curvature.
Okay, let me read this real fast as well then. A whole bunch of different stuff being thrown at me at the same time. Love it.
So the black swan, you can see 10 miles, and you should see at 1.22 miles the curvature. But you cannot see even 10 miles. So I did post 69 miles.
Nice.
Well, wait, hold on. Even if it was at B, hold on. Even if it was at B, that's still further. That's still further than 1.22, man.
That's funny.
So there's no curvature.
It's still over. It's over. Like there's no coming back from that.
And by the way,
okay, hold on. 1 point at a time. You guys are bombarding me.
I just want to finish. Someone did try to debunk these guys going to that place, but they gave up.
They gave up, you said?
They went to this place and they gave up to show the data.
Oh, neat.
Because they found no curvature, so they give up. They didn't find any curvature.
That's neat. I am going to take a screenshot of your thing, of your comment and pictures here, and I'm going to look that up on my own separate time because I'm also curious about that. I can't answer it right now. But I bet you there's a reason.
How are you, PKphoenix? How are you?
What's up? I'm doing good. How are you?
Yeah, not too bad, mate. I heard you say something just then. It was I'm sure there is maths for the horizon, but I don't know it. But I'm sure we can look it up. We can tell you if you want. Miguel just said it in his statement. It's supposed to be, if you're at 1 foot, it's supposed to be 1.22 miles to the start of the curvature, which is what you should call the horizon. So, have you got anything to say about
that? Something that is interesting, I guess here. I think my brain's bouncing in points here. It is interesting. Yeah. All of this is interesting. The conversation, even if I think that the funny thing about these, in general, is that even after we're done, even though we obviously don't agree in our points, I'm still going to go look and see what their actual reasoning is about it too. Like I said, I wasn't expecting to get into a debate tonight. Happy to do it still.
Yeah, yeah, that's all right. What's your rebuttals for what the guys have come up with though? Like when you say debate, like
which one? There's few.
So you have someone has has an argument.
Tell you what.
Someone has an argument, and then you argue against that argument, and you come back with a rebuttal, and then they rebut your rebuttal. Like, has there been something that you feel that you've done better than everyone else, or something that they couldn't rebut, or something that you can't rebut? Is there anything like that? You know what I mean?
PK, you there? Oh, he just rejoined.
Hello?
Sorry, did you hear me or did you cut out?
I heard you, but my mic wasn't picking.
Oh, okay. Yeah.
Mine is and all kinds of fun.
No, that's all right. Yeah. Was there something that like you didn't understand, or you kind of won your debate or you lost your debate, and you want to go back and look at more?
So far, I have been there. We haven't really. Well, we've half stuck to points. There have been different images in here.
Yeah.
But we haven't really.
Did you have something that you presented that you think is pretty good proof that you live on a ball?
On the same situation, yeah. Actually, you can still keep on to Lake Michigan here too, I suppose. Why can't you always see? I think it was Chicago on the other side. Why can't you always see them? Why can't you always see Chicago?
Because the horizon.
There are some days that you can't.
Well, the horizon changes, dude. Horizon changes.
Right. The horizon.
So it's optical.
What do you mean by the horizon?
Yeah, it's an optical phenomenon. Well, if you lived on a ball, the horizon would be in a permanent position. So because we live on a flat plane, it does funny things with atmospheric differences. So some days you can see it in a position, other days you can see it in a different position, and then other days you can see it even further. So why would you, if you had a spherical ball?
I imagine.
Why would the horizon be in a different spot every time you look at it?
Hey, wait, Timbo. Wait, hold on, Timbo. You just misspoke there a little bit. So if the Earth were a ball with a radius of 3,959 miles, the horizon wouldn't necessarily be in the same place all the time, but it couldn't be any further than 1.22 miles at 1 foot observer height. So it might even be close.
Correct. Yeah. Sorry.
This is a fun time to mention that the horizon is a imaginary line as well, because the horizon is not a physical location. So it's a good time. It does change, but a very minuscule amount too. It all is based mainly off of the observer side. I know that.
Yeah. Do boats go over an illusion?
They can go over what appears to be a mirage every once in a while from a viewer way far back.
So they don't go over the. When people say they go over the horizon, they're not going over the curve, right?
The horizon is not a physical place that you can cross over.
Do we?
It is a figure of speech.
Great.
Okay.
Right.
Do we?
So where's the curve then?
The curve is still there.
Where is? So it's still there, but it's not there. Can you clarify that?
There's there is a few different videos as well that I've seen of picture of ships disappearing from the top up as well.
Okay.
Similar to what you've had, which
I know that proves our point. Exactly, that proves our point. We can show videos of boats disappearing bottom up when there is no actual mathematics of any curvature. Anyway, so it's too close to have curvature, but it still disappears bottom up due to atmospheric conditions. So what's it going over there? Because it's not going over the curve of a ball that's 3,959 mile radius, because there's not supposed to be any curve. So this is the thing, like, you know, you guys say it's like going over the curve, but when there isn't supposed to be any curvature there and it still disappears bottom up, it shows that
ironically to what you were saying though,
from the bottom up.
It can be a bit of nitpicking as well, because there are atmospheric conditions and the refraction off the water as well that can make things appear to be disappearing from the bottom up, but not all the time either.
Awesome. Yeah, I agree.
Not all of the time either. And there's still the conversation of on a lot of times with the same things. Why can't you pull a ship that's even farther back? Why can't I see all the way over to England? Atmospheric conditions. I understand that.
Well, you can.
But I mean, why can't you pull, for instance, the Black Swan? Why can't you, for instance, with the Black Swan?
Yeah.
Which is always a fun picture, like we've talked about already.
Well, you've shown you have you're not quite sure about what you're seeing in that in the first place, so it's probably best not you talk about it.
All right, little guy.
Can you define horizon?
The apparent point at which the sky and land touches.
And where is that in the oil rigs images?
He said B.
Due to atmospheric conditions, it's a little
B.
Yeah.
What?
B. He answered in the multiple choice.
I just said B. Yeah, it was a throwaway answer.
Okay.
What do you mean throwaway?
Go ahead,
so
carry on.
What?
What do you mean? What do you mean by throwaway? Are you lying to us?
It is obviously a it was a BS answer. I mean, it was a
what's
best
the real
guess
answer?
scenario.
Okay, best guess.
I haven't
So
spent
your
time with
best
the
guess
study
was B. Okay.
Or A. Actually, if I'm looking at it, A. Sure.
Why don't
We'll go with
yeah?
A.
Why don't you?
But that's
use
still
your eyes?
odds.
Both of those are beyond 1.22.
But that's
Are you aware of that? Are you aware that both of B and A are beyond 1.22?
Yeah.
That's neat. That's cool. There's different atmospheric conditions at play there that are probably causing that.
So you want to play it down and then you want to complain about it. Which is it problematic or what? Are you going to mock it? Which one is it?
I haven't mocked anything that anybody said, man.
No, not successfully. I'm talking about the.
I haven't mocked.
Where's the horizon in the? Is it beyond the oil rigs? Yes or no?
Technically,
Technically,
it should always be.
I'm done,
Technically,
dude.
the horizon.
Up to you, sir.
My guy, are you all right? Are you all right? Is he okay? I haven't been disrespectful to any of y'all.
He's perfectly fine. He's just if he.
No, I've not been. I've been honest with you. I'm sorry if you take that as a sign of disrespect.
You are being disrespectful. It doesn't matter. It doesn't matter.
A little bit.
Hey,
going back to it.
Are they behind?
Don't
Is
take
it
it.
the horizon behind or in front? Is it behind or in front?
Technically, once again, nothing meets the horizon to begin with because it's an imaginary point to begin with.
Okay, so you
Exactly.
What?
The horizon is not a physical location. Nothing can be behind the horizon per se.
Exactly. That's our point.
Okay. And that's my point too. Nothing can be behind it. So where's the rest of the oil rig there?
It's a curve
On the left hand side there. Why does the oil rig on the left hand side appear to be smaller or farther?
Oh, can I
appear to see less on the
Can I
left?
answer this? Sorry, guys. Why does the left hand? Why does
It's
the
a
left
fair
hand oil
question.
rig?
You guys are bombarding me with
Yeah,
questions.
Can I answer it then?
Yeah, absolutely.
Right. Why does the left hand oil rig appear to be distorted? Yeah. Why does the left hand rig appear to be distorted? Yeah. Because it's a still shot taken from a video. If you watch the video, you will see the atmospheric distortion in play. The oil rig is kind of waving about at you. But the question's not about the oil rig. Yeah, we can provide it to you. It's not a problem. But if you could let me finish my point, that would help even more.
Yeah,
because the question's not about the oil rigs. The question's about the horizon. Where's the horizon with regards to those oil rigs? So can you answer that question? Where's the horizon in reference to those two oil rigs?
I can't answer that. I'm not sure. But once again, they should still always be in front of it regardless.
Again,
hold on. The apparent horizon looks to be A, because that's where it looks like the water ends, or you can't see anymore of the water.
That's the kind of sorry, Mr. Chattybox, that's a kind of misnomer, because within the definition of horizon, it's an apparent location anyway. So it's apparent, we understand that. So apparently, where's the horizon?
Hey, doesn't mean that it can't look different due to different atmospheric conditions.
But how many horizons are there?
2. I don't really see why C would be the horizon. I'm guessing that's probably where it's supposed to be.
Dude, trick question. How many horizons are there when you go out into the world and have a look across the sea? How many horizons are there? How many times does the water, the surface of the earth, appear to touch the sky? How many times? 1? Or are there multiple horizons you think you see? You drinking? So how many horizons are there, mate?
There's only one horizon.
Awesome.
Regardless.
So where's the only one horizon in the image?
It's a distorted image. It's an obviously distorted image. There's obviously atmospheric conditions at play.
Yeah, again, atmospheric distortion. Again, we are always looking through the atmosphere. So with all of that taken into account, where's the horizon?
We are always looking through the atmosphere, but there are different atmospheric conditions.
Yeah. Will that affect where the horizon is then?
It could make it look like the horizon is different than it actually is.
Will it affect where the horizon is? Yes or no? Will the atmosphere affect where the horizon is? Yes or no?
Technically, it shouldn't, and I imagine in most equations that you don't. Of that, you can still find out regardless.
Hold on, Chatty. Don't start imagining what you think I know, mate.
Don't fucking call me Chatty, man. What is y'all's issue?
Because
I am trying to answer y'all's questions here. Relax.
Actually, no, you haven't. That's why
I am trying.
Yeah. So why do I have to keep bringing you back down to the horizon that you said 2 minutes ago was fucking imaginary? I've had to point out that there's not more than one horizon, even though you tried to say that there fucking was. So in reference to the two oil rigs, where's the horizon appear to be?
In that image, as I have already said, in that image, as I have already said, it appears that it's at A. It looks like there's more. However, the point that you are running through me, my guy, Mr. Chatty yourself too. The point that you keep running through is that there is a solid point on the horizon.
God. So I had two questions. Come on. I had two questions. The other one was, will the atmosphere affect where the horizon appears to be? You didn't answer that one.
Where the actual horizon is, no. Where we seem to see the horizon, yes. There is still a point on the horizon.
What's the actual horizon?
I don't know it off the top of my head. I imagine it's the 1.7 meters or miles, 1.77 miles.
Yeah,
I'll take over for that.
I get you. So your assertion is we don't see the actual horizon. That's the geometric horizon. What we see is an apparent horizon, right?
Always have. Yes. That is a horizon. Yeah, there is no real horizon.
So good. So you're kind of answering my question for me, but I'll ask it again. Will the atmospheric conditions affect where the horizon is?
Where the horizon appears to our eyes to be, yes.
Awesome.
However, when doing things like sailing, you're going to have a point in the horizon that you're always going to calculate off of, regardless.
No one cares about that.
Or with the sextant, for instance.
So my question is to you: have you ever seen the geometric horizon, being as the atmosphere is always in the way?
Have I ever seen a horizon given the atmosphere is in the way? Was that what you said?
Yeah, that's exactly what I said. So has anyone ever seen the horizon, being as we're always looking through the fucking atmosphere?
Nope, because the horizon's not a physical place.
Oh, awesome. Unless you think the horizon's a geometric location, you fool. Physical
the horizon can still be calculated, yeah. The point at which the sky and sea, in this case sea, appears to be, it is. You can still math that. You can still math that one out. It doesn't mean that's a physical location.
Hold on. If it's physical, hold on. Sorry, Timbo. I do apologise.
No, you're all right, mate.
You do understand that when you suggest that things are blocked by the curvature of the Earth, that's a claim to physicality of the horizon, right?
Say that one more time.
You do understand that when you say, I can't see the bottom of that ship, that's a claim to physical horizon, right?
I suppose so, but at the same time...
Yeah, so you can't have both. You can't
yes,
have
I
both.
can. Yes, you can.
No, you
absolutely can. The position in which the horizon is calculated, and the position where the horizon is calculated... What?
Do you want me to tell you why you can't have both? You can't have your fucking cake and eat it. Because if you're going to claim physical geometric... if you want to claim physical geometric obstruction as in the reason why you can't see that boat, it better be where the mathematics says it fucking should be, sunshine. Being as all me and you have spoken about is the horizon being optical, the atmospheric conditions are going to be the thing that moves the horizon around. So your claim of physical obstruction is kind of removed because you haven't got any physical obstruction. You don't see the physical obstruction you just said. You never see the curvature of the Earth, the physical horizon you just said.
You can see the curvature of the Earth if you get high up enough.
Yeah, so what blocked the bottom of a boat?
It depends on... There are also cases and videos that I can't pull up evidence for right now, because I have to search for them. Of the bombs not coming back up off of them. And in that case, they would be past the horizon. I see the points here.
What's the horizon?
An imaginary line, but in this case, or an apparent line.
Oh God, it's imaginary, or is it apparent? Is It's
apparent. It's not imaginary. It's apparent.
Yeah. So okay.
Technically,
so this is
still
what
an
I'm jumping all over
imaginary
your
point.
word. Yeah, it's not imaginary, mate. This is what I'm jumping all over the words that you use, because imaginary definitely isn't the word that you want to be fucking using right about now. It's apparent, right? So we're trying to get you down to understanding that we don't see the physical horizon where it should be geometrically. The point is, being as the atmosphere is always in the way, you, me, and everybody fucking else has never seen the geometric horizon. So then the question then becomes, how the fuck
thing is
did you get a radius?
There's not a geometric horizon to begin with, or there is a geometric horizon or an apparent horizon that you can calculate off of, but there's not a point that you see it. That's the thing that you're also harping on.
How'd you measure it?
So how'd you measure it then?
You base it off of where the sky is supposed to meet the curvature of the Earth. I know that. I don't know the formula for it.
So 10 miles, 20 miles, 30 miles? Where?
I could not tell you off the top of my head. Once again, 1.2 I didn't come in here with material.
Yeah, we know. We know you didn't come in with any material because we're asking you and you're not listening.
You're still kind of being a bit of a cocksucker about it. And I have been very open to everything that you guys have presented.
Wonderful. That's wonderful. I'm glad that you're such a nice person, but I'm still not going to accept your sofa screen. You're dancing around the fucking point. What I'm trying to tell you is being as you've admitted that the horizon moves around because of the atmospheric conditions, me and Timbo just asked you in unison, well, how the fuck did you measure to it then?
Then let me make this crystal clear then. Absolutely crystal clear. There is a point. An apparent point. There's a geometric point that you can measure the horizon. I don't know what that exact number is. I don't know the formula for
that was
it.
Clear.
It's not answering the question.
However, due to atmospheric conditions, what our eyes actually see could be a skewed version of that horizon. We can still mathematically point it while it appears different to our eyes because atmospheric conditions are anything.
We're not asking you to mathematically backwards engineer it to your fucking preconceived ideas. We want you to prove your preconceived idea.
Okay.
You say that the Earth curves. Right? We're asking for a direct measurement of it, and you can't use the horizon because it's apparent. It's always going to move around, right? Mm-hmm. So being as the atmosphere is always in the way, how the fuck did you actually measure to the horizon to get 8 inches per mile squared or 1.2 times the root of the observer site? How'd you do that?
It's not for my dog's whining, I'll tell you that much. Didn't figure it out that way. But she's still doing it like crazy.
Yeah, that's brilliant. So you're not going to answer the question
of water
or be into
I can
because
joke.
You don't like.
I can.
Yeah.
Listen, man. I can joke around too.
You can joke around just before I stab you with this sword that removes your religion. So you're now going to try and be funny about it.
I do.
Or you're going to be
I do not have religion.
Or are you going to be intellectually honest and go, do you know what, guys? I realise that being as I've demonstrated my understanding that the horizon moves around with the atmosphere, then shit, how the fuck has anybody ever measured to it then? Being as no one ever sees it.
Am I missing a point here? I think that there's a disconnect here. Either well, actually, I know that I may not be understanding what you're saying here. The horizon is a fixed point based off the observer site, and the point at which the Earth begins to curve. Hold on, let me finish. This is clarification. Hey, this is clarification. Let me finish getting out what I have let you speak.
It's not.
Let me get out what I need to say.
Why should I continue letting you lie?
Because I don't instantly believe what you're saying either, but I still let you finish out of respect too.
That's brilliant. But what is that calculation? Because you said, 1.2 times the square root of the observer's height in feet? That's the actual physical location of the horizon?
That sounds pretty close to the equation I've seen in the past, yeah.
Awesome stuff. So you know the picture of the two oil rigs, the observer at 1 foot, the horizon should have been 1.2 miles away, but it's beyond 10. You remember that, right?
That's great. Mm-hmm.
Yeah. So where's the geometric horizon, being as we can't see it because the atmosphere is always in the way? You said that 2 minutes ago.
Things can be pulled past. My brain's apparently caught up now. Things can be pulled up over the horizon as well, thanks to the wonderful thing that we call refraction, that we've also talked about before too. Can you define refraction and give me a citation and an example? You just said refraction. Well, hey, those are actually already in the chat. They're
with
scroll up a bit, they're there.
sorry. Which model of refraction have you used?
Snell's law. Let's go with that one.
Oh, so
That's what
What's the medium?
how many mediums have you got? If we're talking about
2.
Snell's law,
Refracting through the air and then your eyes. Let's go with that.
no.
Nope, we're going with that one. Nope, we're going with it.
Yeah, in Snell's law, it's not your
retarded I am.
It's not your eyes.
Yeah,
Just
I
have
know.
some humility, dude.
It's not your lies. But we're going to be
You
talking
missed
about
the part where you said,
mediums.
"Yeah, I know how retarded I am."
Yeah, very retarded. So we understand 2 different mediums. Let's say water and air. So when we're looking just through the air, how the fuck are you going to apply Snell's law to this, mate?
I'm not sure. I tossed that out there.
But yeah, exactly. That's why I asked you what the fuck you were talking about. And then you turn around to me and say, I'm not sure. So therefore, you're not sure about what the fuck you're talking about, are you? So don't say refraction, being as you don't know what
refraction.
it is. So what model of refraction? You're going to say Snell's law. I'm going to say 2 mediums. You're going to go.
Well, if you want to give me like 5 minutes, and then I'll find out the correct answer to it. The thing is, right now, I'm working on no material and on very old context.
That's fine. That's fine. I do apologise. I should obviously be so grateful that you gave me a bullshit answer that you've now got to go away for 5 minutes.
It's the correct answer that I know that is correct. I cannot properly define it right now. And you're right, I don't know enough. So if you want to drop the subject too, that's fine. And I'll concede the point.
No, I
don't know enough.
Remember when Jedi say you're in a...
Nobody knows what you're talking about.
What?
Remember when Jedi said that talked about your religion? You know why he said that?
Because I know the answer is because of I go off of faith. But that's also incorrect too.
You have a belief with no evidence, yeah.
So you believe this?
No, I trust people to be telling me the truth about this. I don't, and I assume that the entire world and the
trust the TV. You trust the TV, okay? You trust the TV.
They're not all lying. They're as duped as you are, and as I lived several decades of my life. I wouldn't take it personally.
Don't take it personally, mate. Just understand that you don't know what you're talking about, and we're trying to help you understand that you don't know what you're talking about. And with reference to you not understanding what you're talking about, the Earth's flat. Because the stuff that you think you know, you don't.
Mm-hmm.
Clearly. All right. What model of refraction?
No. I need you to understand the stuff that I know to be true. I cannot articulate well. This is old material.
Okay, you're all of a sudden. Let me ask you. I'm trying to be dulcet toned. when you told us about earlier you said everything refracts. Well, how long is it that you've been convinced that everything you see in the distance is an optical illusion? How long have you been going with that?
Define what you mean by optical illusion.
Well, you're the one who said that things are lifted up over the curve of Earth. How about we go with that? Those instances.
It's always been the case. You see mirages while driving all the time.
You see heat on the highway. You see heat emanating off the highway. What I'm asking you is, if you see these long distance observations, if they defy the 3959 spheroid, then what you're seeing is an optical illusion. That's what you're telling yourself. And I'm just wondering, how long have you been under this idea that everything you see in the distance is an optical illusion?
Isn't it crazy how as well, though, that everything you see isn't where it is?
When did you realize
everything is an optical illusion? You're right. You are correct. Everything you see is an optical illusion, including the things that are right.
No, everything you see is an optical illusion.
Oh no, you too, because everything that you see is not in its true place. Thankfully, due to refraction.
Oh, everything's not in its true place. Okay, so I'm holding my phone and I'm looking right at it.
Mm-hmm.
Did I just get lucky?
I do know that. No, that's not.
Dude, you're coping. Okay. What I'm saying is,
you're being.
When did you realize? When did you come to this realization that everything you see in the distance is an optical illusion? That's all I'm asking.
Probably about 5th grade. That sounds about right.
Did you ace the test? Was that on the test?
Oh yeah, nailed that, man.
In the distance, an optical illusion. Yes, A+. Got it. Thank you.
So real quick, everything you look at refracts. You say, right?
Yeah, it does.
Okay, so everything refracts. Is Earth curve a thing?
The Earth curving. The Earth.
Yeah. Is Earth curvature a thing?
I feel like I'm setting myself up here, but yeah.
Okay, how do you know that?
A couple different things. Interestingly enough, once again, I haven't seen the curvature with my own eyes. However, I will go back to my original point. Nor have I done any experiments myself. I will go with my original point of saying that I do not think literally billions of people are lying to me.
Oh, hearsay. That's how you know it's a thing. Okay, that was
it's not hearsay. Thanks. when there are, and I know that I have seen them before. There's tons of research put into this too.
They wouldn't have to be lying.
Okay, but why would you just cite research? Hey, if there's research, why not just cite that instead of hearsay? That would be more compelling than the hearsay.
My guy, man, have you not heard me this entire time? Genuinely, in the past, when the couple times I came in here, I did come in here prepared. That wasn't my intent tonight. I was here.
So I should have listened to you one of the other times, not this time.
Yeah, you know, sure. Honest to God, this whole
interject, guys. Hold on. Can I please interject? So wait, you just said two things. You just said you wouldn't believe that billions of people have been lying to you, but you also just said you've never seen the curvature of the Earth with your own eyes. So let me ask you: do you think billions of other people have seen the curvature with their own eyes? Because I mean, it would only be astronauts, right? So it'd only be a couple hundred people, a few hundred people, not billions of people, right? That have seen
the curvature of the Earth has been proven through experimentation before. Plenty.
But hold on. But the point I'm trying to make is, why would you say the words? My question is to you: why would you say the words "billions of people are lying to you" when they've never seen the curvature?
You're right. Let me rephrase that to millions, and that includes people who are in the consumer.
You're stuck in concrete thinking, dude. You're missing the point.
No, there's
no, because I have logic to it.
But the logic seems to be that many people. That many people can't be wrong. Go ahead, Orion. Sorry.
Well, I mean, just keep in mind, it's only just barely above 600. That's the number of people, somewhere around 600
that have seen the curvature of the Earth. I get that.
That claim that they've gone to just listen, dude. That claim that they have gone to a medium known as the vacuum of space, a medium that we don't believe in. So only in that place would you ever have a chance of ever seeing any curvature of the Earth, right? So there's only 600 people, and most of those people are low Earth orbit. So technically, at low Earth orbit, you're not even high enough to technically see it according to the curvature of the Earth, mathematics, geometry. So technically, the only people that actually have gone up in their paradigm, in their story, the only people that have actually gone into space and gone far enough to see the actual curvature of the Earth are only the people that ever went to the moon, which will be a much smaller number than 600. So, again, question, like, I'm just saying, like, rethink your statement when you say, like, this number or that number of people are lying to you. Just rethink your statement.
One sec. Look something up there.
This is a good
The statement isn't that that many of them are lying. People are just fooled. Your teacher.
So you can see the curvature of the Earth at about 6.5 miles up. That's what I had to look up there.
No.
You start to see. You'll be able to start to see the curvature.
Sorry. I do apologise. You're talking about left to right curvature. Left to right.
Sure.
Okay. Is that from one side of an aeroplane? Because I'm going to tell you to go. Because I'm going to tell you to go to the other side of the airplane, be the same phenomena. Then I'm going to ask you to go and speak to the captain. 1 sec. Okay. God, I hate it. I hate it when people do this.
You're right. I misspoke. I gotta recorrect myself there.
Yeah, you should do.
I gave an. Why do you got to be such a dickhead, man? If I notice I say something incorrect, I'm trying to correct myself. You don't have to be a cocksucker about it, dude.
I'm not being a cocksucker. I literally shut up so you could correct yourself.
You made a sarcastic remark as you were finishing off there. It doesn't matter. It's been a routine. It doesn't matter. It doesn't matter.
Do you want me to explain to you why? So
something's the trigger.
Stop swearing. It's against the rules. Okay, you can see at the top. Welcome. Okay, just that. Phoenix.
That rule is bullshit.
My bad. I didn't. I didn't realize that. My bad.
Okay,
I joined the server ages ago.
PK,
what's up?
PK, you understand how going 6 miles up and looking out the side of an aeroplane is kind of silly when you're talking about left to right curve, right?
Yeah, which is why I immediately backpedaled that statement, and I was looking up the correct things here. I understand.
Okay. So what are the correct things then? Being as we've told you that the math says you shouldn't see the curvature of the Earth, left to right curvature, from the height of the International Space Station, and you said 6 miles. So where are you going to go now?
So it looks like it's about 140 miles up that you can actually start to see the curvature decently well. I'm doing quick Google searches here.
Is that left to right curvature again?
I'm not sure. I'll have to look it up. I'm imagining at this height it is.
Yeah. So left to right curvature, right?
Mm-hmm.
What's the difference when you go to the other side of the aeroplane and you see left to right curvature, and you go to the cockpit and you see left to right curvature? If you add all those lines together, as in connect those lines, you don't get a circle, do you? You get a wibbly wobbly line, don't you?
I'm imagining so. I haven't heard that argument before, so honestly, I could not tell you.
Well,
that's the first time I've heard that.
Well, think about this, right? You're on one side of an airplane and you look out the window and you see left to right curvature. I look out the window and on the other side of the plane and I see left to right curvature. If we connect those lines, are we going to get a sphere?
I'm trying to actually think about that. And
the answer is no. The answer is no.
Yeah, I'm not sure. That feels incorrect. I'm not sure if I don't know anything about it. That doesn't feel right, just geometrically speaking, but I can't say for certain, so.
That's okay.
They don't add up.
Like a McDonald's sign, wouldn't it?
Yeah.
What?
Be like a McDonald's sign. Think about it.
Or you just continue the curve until you get to the other side in your mind around the plane. It doesn't work like that.
What?
Go to
if you have left to right curvature on, say, the left side of the plane, and you're looking at left to right curvature, and then you go to the right side of the plane and you see the exact same thing, they can't join up. Like if you extrapolate that further out,
exactly.
That's the simplest way. Yeah. They're saying like if you panoramic it, you'll get the wibbly wobbly line.
Let's do this. Let's do something a little bit different now.
So, but before you move on, do you understand it? Though?
Like I said, I wrote it down. I'm gonna have to.
So it's not the Earth that's curving. Is what the answer is, because
if that's what you want to say, sure. I genuinely don't believe that's correct answer. But I can't come up with a counterpoint because I know nothing about it as well. So honestly, I can't.
Just think about it. Like, how can you have it curved on one side, curved the same on the other side? How does that work?
Look, you're just a man.
I'll find out that.
You're just a guy with a 360-degree view around him. It looks a little bit curved. Go to the top of a mountain, look in front of you, you'll see curvature, mate. I guarantee you see curvature. But imagine you turn 90 degrees and you see curvature there. Turn another 90 degrees, you see curvature there. And you turn another 90 degrees, you see curvature there. In every single 360-degree point, whenever you stop, you're going to see curvature around the periphery of your eyes. That's just an optical phenomena. You understand what I'm saying now, right?
I do. I see, or I've seen what you're saying. Although you saying that it connects and it's all wibbly wobbly, that's the part that's getting me there.
So if you just pan your head around, like if you took stills of, say, the cockpit, the right side of the plane, the back of the plane, the left side of the plane, right, and you saw curvature from each one of those points. If you just pan your head around, it won't be just continually curving. It'll have to go back up to meet the left-hand side curve, to meet the right-hand side curve. Do you understand? That's the wibbly-wobbly part.
Like I said, I understand where you're coming from. and then I can partially visualize it as well.
Right. He's not saying it actually happens. He's saying if you saw curvature, this would have to be the case. I'm not saying it actually happens. Yeah.
Otherwise, it's something that's causing that optical illusion of the curvature. So it's not the Earth that's curving.
Awesome. That's something I want to look into a bit more as well, because once again, curious. Sounds interesting. Something else I like to do now too is obviously I'm a little rusty on all my flat Earth knowledge, or shitting on flat Earth knowledge.
It's not flat Earth knowledge, man. It's just like if you just think about that concept.
That one, yeah, maybe so.
You're seeing curvature.
Something about that feels off. I'm not saying that it is. You could be 100% correct. It could be an optical illusion.
That's what's up.
No. I said before that it feels geometrically speaking off. But
of course it does, because it's not curved. That's the whole point.
Awesome.
It's really hard.
I have nothing to discredit I have nothing to discredit
it. It diametrically opposes your idea.
Think of moving on, lads. Hold, calm, relax. I can see the point if that's what you want to hear. Hold on. I can see that point if that's what you want to hear. What I'm trying to do is move past in a different direction here too. I'm obviously very rusty.
We're just making sure you understand. That's all. Big thing.
Mm-hmm.
Next.
So this isn't quite next. I want to do something a little bit more. Probably fun for y'all. It's obviously been a while since I've done any of these debates. Obviously, I've done dog.
Not really a debate though, is it?
Tonight, no. It's me trying to frantically recall literally things I haven't heard in over a year now.
But if you're not going to move to your next segue, then I'll just move to mine. Is globe Earth knowledge a thing?
Let me get my point out here, Dick. And because it's a whole different subject. I didn't even hear what you said, and I apologize for that.
All right, fine.
It's not a separate point. What I would like, if you guys would be willing, is to tell me your favorite bits of flat Earth, or your favorite flat Earth proofs, and let me know them. And then I want to go back and research them again. A lot of them I've probably heard before.
Water. All right,
What about water? What about water?
Well,
the flatness mostly.
Yeah.
Level. Not flat.
Whoa.
Direct measurements. The fact that there are no direct measurements. There might be direct measurements.
Well, you said level, not flat. Would you be able to describe the distinction?
Flat, it would be... I can't remember the exact definition for flat. Flat... I actually can't define flat right now. Flat would be having completely parallel smooth. No, not parallel. Completely smooth. No...
Undulation.
What are they called?
I hope you know I'm a builder.
Higher or lower than the other?
Yeah. So be careful what you say about level.
Level is oh my fuck. Apologies. That one slipped out. My sincere.
So you wanna tell us the difference between level and flat?
Level is water. Level is water. Level is talking about water level. That is the definition of level.
What does level mean? What does level mean? If you're saying level is water, water is level, what does level mean?
What's the spirit level?
Level to what?
Horizontal.
Would
that be it?
What's horizontal?
Horizontal. Horizontal. You know what? You're right. Let me not try to start a separate debate here before I get to my original thing. It's getting late and I need to hop off soon. I'd rather hear everything that you have to say. I'm going to put that as well, talking about the difference between level and flat as part of my research too. So I can actually properly give a proper answer to that.
Okay, so it's the surface of... Yeah, go ahead, Jedi.
No, so I was just going to give him my flat Earth point, mate, but I'm only going to talk about a fucking triangle, so you carry on.
Well, does the surface of resting water have any parts that are higher or lower than any others?
Surface of resting water?
Yes.
In large amounts.
Yeah, you're talking about in terms of the ocean?
Well, let's just take, I don't know, a glass of water and just go out from there to any scale you wish.
A swimming pool.
Yeah, I like the swimming pool better. Let's do that.
It's easy to conceptually grasp.
Well, I do know that water does like to stick to itself or to the sides of things on certain occasions. So, I mean, yeah, technically. With a glass of water, you can see the water trying to stick to itself. But either way, I wrote that down.
So technically, the glass of water has parts of its surface which are higher or lower than the other parts.
What happens?
A glass of water, sure, yeah.
And what happens when you spin the glass of water at 1,000 miles per hour and you put it in a vacuum? What do you think happens to the water?
Gravity keeps it touching. It's crazy.
Shit, yeah.
Keeps it connected.
Evidence for
Good
gravity
stuff.
working on.
There is a metric ton of it, and I'll come with it next time. Okay, I will next time I come in here.
You better
and that's why
an open vacuum, by the way, because that's going to be my. You need an open vacuum to demonstrate gravity holding gas next to it, just so you know.
You might.
So you wouldn't describe the surface of water at rest as being horizontal, then?
It's not perfectly horizontal. No.
Well, okay, the horizon that's horizontal.
By the way, hold on. I don't want to move into the points. So I have that point as well. What's somebody else's point? I want to come back in here with content and good talking points.
Do you know what a triangle is?
You're going to ask me if the definition, I might not be able to hit you off the definition.
Okay, but three straight lines meeting at three corners where you can measure and add the interior angles to 180 degrees. That's a triangle, right?
Yep, that would be a triangle.
Awesome. Can you measure an angle or two angles with inside the triangle if one of those lines of the triangle is bent or curved?
Bent or curved?
Yeah, curved. If one of the lines in that triangle is curved, can you measure what two of those angles?
I'm actually not sure of the answer off the top of my head. I want to say yeah. That sounds like an obvious yeah, but
yeah, being as I've defined a triangle as three straight lines where you can measure the angles because you've got three straight lines and they reach 180 degrees. But now I've bent or curved one of those lines in a triangle and I've asked you if you can measure those angles. Can you measure the angle if I've curved a line within a triangle?
Yeah, because I know that I think they also have a specific name as well. But
yeah, so no is the answer. You cannot measure an angle if one of the lines is curved. Right? If you've got a 90-degree angle triangle and I curved the baseline of that 90-degree triangle and you tried to measure with a protractor the 90 degrees on that triangle where one of the lines is curved, you wouldn't be able to measure 90 degrees, would you?
So out of curiosity, what is the point for the flat Earth there with that?
Oh, I'm going to be talking about celestial navigation and navigating with the stars and reading elevation angles up to stars. That's what I'm going to be doing.
Celestial navigation. Got it.
Yeah, so celestial navigation is based on right-angled triangles. You make a triangle between 3 points. You, with your angle measuring device known as a sextant, the star up in the sky, and the GP of the star on the surface of the Earth. 3 points, you, the star, GP of the star. So, to measure an angle, you require all of those two lines at least to be straight, right?
Mm-hmm.
Okay, so if the surface of the Earth was curved, you wouldn't be able to measure angles now, would you?
I can't say for sure one way or the other right now.
Okay, but you
if you want to give your point, I understand the premise. I do. If you want to, if that's what you want to say now, go for it. And I'm looking it up for my own research for later.
No, that's absolutely fine. Celestial navigation is based on the right-angled triangle. The premise is a right-angled triangle. You can't have a right-angled triangle on a curved surface because if you have a curved surface, you're not going to be able to measure two of those angles. The two angles in question are your elevation angle up to the star in question, and the other angle is the GP of that star in question. The GP of the star is always 90 degrees. Now, it's impossible to get one 90-degree angle on a curved surface, but you must remember that every single star up in the sky has got a ground position of the Earth, and that ground position is 90 degrees to you, a flat horizontal baseline towards you with the sextant. To use celestial navigation with angle measuring devices requires the Earth to be flat. If the Earth was a curved surface, we wouldn't be able to use the sextant, which was designed to be working on flat horizontal baselines. So that's my point. The Earth is practically navigated across and required to be flat when using angle measuring devices to stars.
What is great about that is I know that there is a counterpoint to that, and I can't bring it up right now, but I know that I can come back and contest that.
That's fine. I'll do it for you. You'll say tangent. I'll say what is your dip correction or your altitude correction and why do you even have it in the first place. What I'll do is I'll put the section on the floor so you don't even have to correct for anything. Your altitude or the dip correction to the horizon. So we'll remove the tangent line that you think that you got. My next question will be, how far away is the GP of the star? We'll talk about Polaris. It's over 3,000 miles away because that's how you got your latitude lines.
Mm-hmm.
That's 3,000 miles of a straight horizontal baseline. I can take your tangent away because I know why you're correct. Your dip correction or your altitude correction takes you down to the surface of the Earth. That's all it does. So you can draw your tangent if you want from altitude, of course. You've got to get a relative position down towards the horizon. But your dip correction or your altitude correction will take you down to the surface of the Earth, 0 feet above the surface of the Earth, so you've got a straight horizontal baseline. You can go away and find that, but we've already had the conversation.
But what was the last bit?
You're just going to come back with tangent line, mate. That's the only thing that anybody ever said.
You actually said you brought that up, and you're probably correct. So I already put that down and to research a counterpoint for that one as well. I'm not going to come back here looking like a dipshit for a second time.
No problem.
You would need a curve for that counterpoint.
Anybody have any more flat Earth proofs that I can jot down?
Direct measurement.
Direct measurements of the curvature of the Earth. I take it.
It's the
or
the
vice
laser,
versa.
It's just the laser test. The laser test.
Okay.
Have you heard of like FE Core, John whatever, Dr. John D or whatever? Have you heard of those?
I'm not sure. No. I'm gonna say no. I may have, but I don't remember the name.
I'll post it here. Let me 1 sec. We have it. I'll just post it. You see this channel. This I just posted it in the live stream voice text. This channel #laser test. It's basically the same concept as it's slightly more intense than that long distance It's basically, think of like the Michigan picture, or sorry, the Chicago skyline picture that we talked about, but instead of using the skyline as a target, you're using like a very specific you're using light like a laser, and instead of like a whole skyline, it's like a very specific series of targets, or like one target basically. So yeah, that's basically.
Good to know. I have also copied over that video too. Thank you.
Yeah.
What about gas pressure without a container?
You got that one. That's the big one. You ever?
I wrote that down separately before we even started talking about this. Yeah.
Oh yeah. So let's get into, or do you want to get into that, or do you have to go?
I wanted to get a couple more points. For talking points later, and it's on or 2:30 here. I'm way up later past.
Real quick, last night we were talking to a girl who told us that she was aware of a paper where it's been documented that somebody has used gravity as a container for air, but she couldn't find it. Could you maybe in your searches Google that one up for us and try to bring it back? That'd be awesome. Thanks.
I have a feeling I'm not going to be able to find that specifically. I have a feeling that what's going to happen is I'm going to find something else separate.
Yeah, we couldn't find it. She promised. Yep. She swore up and down that she knew it was out there.
People say a lot of things.
She was going to lay it at her feet, but we didn't have it.
Yeah,
didn't get it. So.
The difference. I have tried my best not to peddle false information. It might not have been the whole truth, or the entire things brought out. But I haven't tried to peddle bullshit either. Right. That sounds like
I won't hold you to it. Just putting it out there. Just really want that paper.
I'm not even sure what experiment
any information.
I have offered base level information. The difference here though is that I haven't looked at this in a while, and you guys are obviously very well versed. So I have to do more research in order to figure it out.
Oh.
Hey, into the break, one. My guy, chill.
Just sometimes you got to ignore the comments. Sometimes you got to ignore the text chat, but
I did not say anything bad. He's just doing. He's just been going off. I'm not sure what. I've said here plenty that I came into this self-prepared.
I'm sure he's got a point.
He's just parroting what you guys are saying, just in a more condescending way. I mean, it's cool. It's just it's what he's done the entire time from what it looks like.
The thing with Discord is like I wouldn't take anything personally. Yeah,
I don't.
Yeah.
On top of that, that's not fair. That's not fair to say. But yeah, no, I don't take very much personal to begin with. I'm not gonna get my feelings hurt being in here or having shit talk to me.
Once you hang up, like you don't know anyone in here, so it doesn't really matter.
Yeah,
like,
no, genuinely, you guys. At the whole end of the day, I don't matter to y'all. Y'all don't matter to me. So it doesn't matter what you say.
The conversation matters.
The conversation does matter, and which is why it should also be given in a respectful manner.
A flat earther.
That's not gonna happen.
Whether you
it's gonna matter really.
What is your profession?
See, old friend, I brought more soldiers than you did.